Everybody, can you guys hear me? Can you see the screen share?
Yes, I can hear you and see the screen.
Fantastic, thank you. All right, I've got a poll up just asking you about your experience with Eclipse thus far. In general, obviously, it should just run and be perfect. And you know, probably 99% of the time it is, but every once in a while it gets really cranky. The solution tends to be to uninstall Java, uninstall Eclipse, reinstall Java, reinstall Eclipse. If there are no questions, I'm going to end the poll and then let you guys see the results too. So again, it looks like 70% say it's working perfectly, 20% say it's a bit slow. Nobody's running into terrible trouble. I thought I'd start out with a kind of a quick little app build that you guys can follow along with. A bit to review the material last time, and then also to segue into the material this time. So we're going to build a little touch panel app like we did last time. We're going to hook up the MouseListener to it, and then we're going to change the color when you click on it. And it's kind of cool because we can change the color of the panel, and we can also change the color of the JFrame. And if we give those two different random colors, it's kind of cool. So if you want to follow along, that's what we're going to start out with. Then we'll dive into chapter 5, but we'll already have covered colors, so we'll be a little bit ahead. All right. Okay, so I'm going to head to Eclipse. Well, let me show you what this will look like when we're done. It's not a huge app, but just to give you a sense of what we're building. Every time you click it, we'll get these random colors. So it's randomizing the panel and it's randomizing the back of the JFrame, which at least on the Mac we can see sort of as a pastel hue because you're seeing it kind of behind the frosted window title bar. That's what we're going for step by step. So I'm going to start a new Java project for chapter 5. So I'll say new Java project. I'm going to call it chapter 5. I'm going to not create a module. And I'm going to highlight the source folder and say new Java class. I'm going to call it, how about ColorTap? I think that's what I called it a second ago. And we'll just build it up step by step. I do need the main method since it's an app. So I'm going to remember at least this time to click what method would you like to automatically create. So I want the main method, and you could say it was a subclass of JFrame and it'll do that for you, but it seems easier to me to type extends JFrame than to try to pick it out of a list. Anyway, I'm gonna be doing the typing and I'll say what I'm doing and I'll try to be slow, but if you feel like I'm leaving you behind, yeah, just have me slow down. So I'm gonna reorganize imports, which is the keyboard combination. On the Mac, it's Shift Command O. On Windows, it's something like Shift Control O or Shift Option O. You just got to pull down that menu and see what it says. I'm going to create the constructor method, so it's named the same thing as the class, so ColorTap. And then I'm going to set the app up in our main method. I'm going to zoom in too, sorry, since you guys have a chance at seeing this. So we'll create the app by saying ColorTap app equals new ColorTap, and then app.setSize. So that was 400 by 400. App.setDefault close operation, exit on close, and then app.setVisible true or just app.show. This is all the stuff we've been doing for the last couple of classes in terms of creating apps. It is not event-oriented yet. It doesn't have any widgets in it yet, but it would create an empty 400 by 400 JFrame if you wanted to load it right now. Instead, we're going to create the panel. So I'll say JPanel P equals new JPanel. Reorganize imports. Here in the constructor where we set up our interface, I'm going to add the panel. And again, just as kind of a refresher, the JFrame by default uses something we call the border layout, which gives us 5 named regions to put stuff in, but we're not using those yet. As a preview, the named regions are essentially compass points. It's north, south, west, east, and center. So you can put stuff in one of the named regions, or you can just add it to the whole JFrame, in which case it will expand to fill the whole JFrame. We could run it now and it still would not do anything because the panel has the same default color as the JFrame, so you would just see a big square in this kind of light gray color. So we got to make it a little bit more interesting. So let's add the MouseListener. And for you guys who are here and are following along, I'm going to use a different syntax so that you get a hang of this as well, because for some apps it's actually easier to do it this way, I think. Okay, so I'm going to say p.add MouseListener, and I'm going to let Eclipse auto-complete it just by hitting return. Instead of typing the keyword this, though, I'm going to type something else. I'm going to say new space MouseListener, open close parentheses, open curly brace, hit return. And so if you followed along, you'll have a little bit of code like this with lots of red underlining. So it's not, it's clearly not ready. So the first thing I'm going to do is reorganize imports. That'll make one of the two errors go away. So let's hover over the other error and just see what it says. It says the type MouseListener must implement the inherited abstract method MouseListener, MouseEntered, and all the other 5. Again, Eclipse will fix those for us. All I have to pick is add unimplemented methods. So that's what I'm going to do. And now I've zoomed in so much it's hard to see. So let me zoom out just so you can see the whole thing. So you can see Eclipse has now added the 5 required event handlers and inserted, helpfully, a to-do that says you need to put some code here, and then also a blank line. So it takes up a lot of space, right? I mean, this is now eating up lines 24 through 52 just to list out all 5 of these. Just as a reminder, for MouseListener, you have to provide all 5 event handling methods. They do not have to have any code in them. So if you want to make them much smaller, you can literally just run through here and delete everything between the curly braces, except we're going to use mouse clicked. If you don't like this syntax, you can use the other syntax. You can add the implements MouseListener to the public class and then add the unimplemented methods at a different location. This is essentially attaching the MouseListener to the panel itself rather than to the app. Okay, we still haven't done anything, so let's do something. I want to set the color on the panel. So we set the color on the panel by creating, there's several ways to do this. Let's just do a quick example with a color. So I'm going to say you can create colors by passing 3 decimal numbers, which would be % of red, % of green, % of blue. Or you can use numbers between 0 and 255, integers between 0 and 255. And actually there's also a syntax for using hex codes. If you're familiar with like web design colors and hex color codes, you can do that as well. Actually, just as the simplest example, I'm going to start with one of the built-in colors. So I'm going to come back and create a custom color in just a second. But for now, I'm just going to set the background color to whatever. You can use your favorite color, but I'm going to say p.setBackground. And then the built-in colors are in the color class. So you hit capital C color and then a period or a dot. And then pick the color you want. And you might scroll over that list and think, wow, there are actually a lot of built-in default colors. But then if you keep looking, what you'll notice is, wait a minute, there's black, all lowercase letters, and then there's black, all uppercase letters. What's the difference? So this is actually where Sun was inconsistent. These are public static attributes of the color class, and by convention, they should be given all uppercase letters, but Sun didn't do that. Sun gave them lowercase letters. And lots of people wrote apps using the lowercase letters for years, and then at some point they decided, well, we just have to fix this. It's embarrassing. So they added the uppercase, the correct uppercase versions, but the lowercase ones are kept for backwards compatibility. So you can actually pick either one, but the proper one to pick would be the all uppercase one. So we've got black, we've got blue, we've got, and cyan is not a color you ever want to use. It's obnoxious. So pass that by. Let's go green. So now we have this should be a workable app. Unless I've forgotten something, that's always a possibility. This should create a 400 by 400 rectangle with the J-frame that when I click on the panel should turn green. There, and that's an obnoxious green. I'll be right up front with you. I assume it is on your screen. I can't stand that, so I'm going to darken it. So you can actually use the ... syntax. So to the color green, I can say dot darker. I didn't even do that twice. Darker. This was step one, which is just the app with a panel. When clicked, it displays a nice deep green. Okay, but I wanted to make it a little fancier, so I want to do, like I showed you at the beginning, I want the random colors. I want the random color for the JPanel. I want I want the random color for the J-frame to get that kind of cool contrast. So we're going to take a couple steps to make this more sophisticated. One of the things I want to get you guys used to is writing methods. This app has a lot of methods, but Eclipse has written them all. So that the other power in programming is to be able to write your own methods to make your own work more modular and more reusable. So something we're going to do a fair amount of for fun is generate random colors. So I'm going to create a really quick method here to generate a random color and then show you how to call it. We haven't gotten to the chapters on methods yet. I think that's chapter 9. We will get there. But I also want you to have the experience of simply writing them as they're needed and not have it be something that is a surprise, in chapter 9 that you think, oh my gosh, I didn't even know you could do that. I should have been doing that. So any place I feel like would benefit from a method, I want to, as I'm showing you this, write the method. So methods have a very standard syntax. There's a data type that they return. So I want this to return a color. I'm going to call the method getRandomColor. And so if you're following along, it's underlined, which is always distressing. But if you hover over it, all it's going to say is this method must return a type color. So what's it talking about? It's mad at us because we've said this method is going to return a color, but we haven't created a color or returned a color. So Eclipse says, hey, essentially you're lying. So you can make this go away by just returning something default. So I could say something like return color.black. That'll make the error go away. The yellow underline is a warning, not an error. It just says you haven't used it. So it's already complaining that you just wrote this method and you haven't used it yet because it's not even working yet. So as soon as we use it, that warning will go away as well. Okay, so 2 ways to create random colors. The 3 decimals tends to be the one most people use. And there's an easy way to get a random decimal number in Java using math.random. The problem is math.random returns a double precision floating point number and the color constructor won't take it. It will only take floating point numbers. Oh, I have somebody in the waiting room. All right. Welcome to the live video. If you're just joining, we are doing a quick walkthrough of a kind of an activity that blends chapter 4 and chapter 5 before we dive into chapter 5. So I'm going to make use of a class called random. As I'm typing, I'm going to redo the import. So I've created a random number generator, and then I'm going to create. There's different ways to write this, but I need 3 random numbers, and they're floats. So I could say float red equals rand.nextFloat. Float green equals rand.nextFloat. I forgot the semicolon, and then float blue equals rand.nextFloat. Okay, and then I'm not going to return color.black. I'm going to return, oh gosh. Well, let's make a color. I want to make this as explicit as possible. So I'll say color C equals new color, and then inside the parentheses I'm going to say red, green, blue, and then I'm going to return C. Instead of returning black, you could compress all of this into one line of code if you wanted to. And if that's more your style, feel free to do it. But for the most part, that tends to be more difficult to read. So instead of color.green darker here, I'm going to say get random color. And so as soon as I do, you'll see the red underlining went away on set background and the yellow underlining went away under get random color. So every time I click, I'm going to get a new random color. And then the last step is to change the JFrame. So you can do it in the same place, mouse clicked. I'm just going to say set background. You could say thing. And this should give us this kind of funky app where every time you press the button, you get a different random color on the panel and a different random color in the title bar. Obviously, every time it's rolling the dice because you're afraid I might get cyan. All right, I think we avoided getting cyan. So this gives you an example of everything we covered last time, which is event handling, the MouseListener, but also now gives you an example of working with colors. Colors have 3 components, red, green, blue. Also gives you a quick example of using a random number generator, which is built into a class called random, and also an example of writing a quick method to reduce the amount of redundant code. So if I'm going to do random colors frequently, I don't want to cut and paste all of this code where I want to create a random color. I just want to be able to say, get me a random color, and I can easily write a method that will do that for me and make the rest of my coding easy. If you have written something like this out, and then you realize, oh, I need to do this lots of times, I should have put it in a method, you can actually ask Eclipse to put it in a method for you under the Refactor menu. It may not work here because it's already in a method, but it's here, Refactor, and extract method. So if you have a chunk of code that you're thinking, maybe I should cut and paste that so that I can do the same thing. Again, you're much better off making a method and then calling the method. That is the ColorTap. So let's jump over to chapter 5, writing and drawing on screen, which essentially we have already started. If you're watching the keynote live, it's on this screen, apps with a GUI, which just makes the point that pretty much everything I do is going to have a GUI. There are books, beginning, CS textbooks for Java that never get to the GUI. The entire introduction is you're doing everything at the console, which is perfectly fine. It's just, it's not as much fun, and certainly it's not as visual as having an interface and using colors and widgets and stuff like that. So that is the focus of my book and my classes is not console-based apps, but GUI apps. So a couple things to know. There's a lot of detail in this chapter, and I've carried over a fair amount of detail in this keynote. If you've looked, it's how many slides is it? It's 38 slides. So there is a lot of detail, and it's not necessarily detail I feel like I need to get into for everything. But so if I skip over something and you found it confusing when reading it, be sure to stop me and ask a question. The first thing to know is this pixel coordinate system. We talked about this a little bit last time, and that is, well, first off, how do you locate anything on screen? You locate stuff on screen by using an XY pixel coordinate system. So your screen is composed of a certain number of pixels horizontally and a certain number of pixels vertically. As a little example here, I've got this sort of simulated graph paper, and you can see that the 0, 0 position for this coordinate system is in the top left corner of whatever it is we're considering. That could be a JPanel, that could be a JFrame, it could be a JButton, it could be anything. They all have their own coordinate system internal to them that starts at the top left corner, counts positively to the right for the x-axis, and counts positively down for the y-axis. So we're on the graphics object slide. To do any drawing in Java, like to draw a circle or something, we need access to something called the graphics object, which is easy to get. You can see the syntax there right here. It's graphics G equals whatever you want to draw on, like a panel dot get graphics. So if we had a panel named panel, the way we would draw on it is to typically is to call a line of code like that to acquire access to the graphics object, or we'll put the drawing in a location that already has access to the graphics object. But one way or another, to do the drawing we talk about in this chapter, you have to have access to the graphics object. There are a couple of complications because it's not available everywhere in your code, and it's also not available when your app first starts, which is the big wrinkle. So you don't get access to G until your UI is completely rendered. That is, all the widgets and everything's drawn on screen. That's obviously an issue if you've designed something using these draw statements we're going to talk about, like a company logo or something for your app or whatever, and you want that to be displayed when your app starts. You can't do it using the simplest of approaches you might think, because you can't get access to G when the app starts. If you try to, G will be null, and then if you try to do something like draw using a null object, you'll get a null pointer exception. All right, so there's 3 solutions, and we're going to do all of them, but in the end, number 3 is the best. The first is the simplest, and that is don't draw anything when your app starts. Instead, launch an app with a button, and when the user hits the button, then draw what you want to draw. That works fine because the user can't hit the button until after the UI is rendered. Therefore, the graphics object is available. So it's essentially a way to add a step to make sure that the graphics object will be available. Second technique is to make your own method called paint and pass it a graphics object and then put the drawing code in that method. That'll work as well and then does not need the button. And then the third approach is to create a custom JPanel which does all the drawing, and then add that panel wherever you want it on screen. And when it is loaded, it will draw on itself. That's the quickest, smoothest way to get what you want to work. All right, these are the basic shapes. You can see there's line, rectangle, rounded rectangle, circle, arc. My arc's not awesome, but it's hard to do these in Keynote. And then the star is just to represent a polygon, so some shape with multiple points. The manner in which you draw these is all the same except for the polygon. So I'm just going to tell you the basic technique for the simple shapes, and then I'm going to jump to polygon to show you the more complex way that it works. But each of these shapes requires you pass Java information that tells it how to draw it. And this is typically in the form of a pixel coordinate, and then maybe additional pixel coordinates, or a width and a height, or in the case of the arc and the circle, you can also tell it the amount on the circle or oval that you want to draw by giving it 2 degree values. These are all integer numbers, so super easy. There's no such thing as a fraction of a pixel that we can address. So when we give pixel values, it's always just whole numbers. Like you can see in this example, draw a line 50, 50, 100, 100 down here at the bottom. That will draw a line on your panel from 50 pixels over and 50 pixels down from the top left corner to 100 pixels down and 100 pixels over, again from the top corner. All of the other shapes work using a variation of this technique based on what the shape needs. So rectangles need a top left corner location and then a width and a height. Rounded rectangles need the same exact thing, but also need two integer values that give you the degree of rounding to the corner. Ovals are same basic thing, top left corner, width and height. The arc gives you top left corner, width and height, and then the degrees you actually want to draw on. So do you want to start here and draw over to here? So I've got a little playground app that lets you draw arcs and specify start and arc angles, and it'll draw for you what Java will actually draw. So it's in the chapter resources for chapter 5, and it's called ArcPlaygrounds, and you can add it. I think you can just add it to your Eclipse project if you want to and play around with it. The start angle starts from right here where my mouse pointer is and goes 360 degrees counterclockwise. So if I want this arc, this is going to be a 90-degree start angle. And then the second angle is the size of the drawing, the arc itself. And this is around 100 degrees, 110 degrees, something like that. So to get an arc like this that's shown here, you would have the top left corner, the width, the height, and then the start angle of 90, and then the arc angle of, let's say, 110 to get something like this. Again, we don't draw a lot of arcs, so although it is a little bit confusing, you can always go back to the playground if you want to and queue it up and enter your values and get the arc that you want. All right, polygons. So this is the one that's really different. Polygons can have a few number of points or a bunch of points. They don't have to go in a particular order. Like mobile apps, they were supposed to go clockwise and weren't supposed to intersect. Java doesn't care about that. You can add the points in any order that you want to. The shape can intersect itself, which is a self-intersecting polygon. Again, Java's happy to be making you a polygon, and there are no limits or restrictions. To get that kind of additional complexity, though, we use a class called Polygon. So there's capital P Polygon, and it's a class. So we'll create a polygon object using the new instantiation syntax. One of the things I have a tendency to do in these examples, though, is I'll say polygon P and work with it as P, but then I also have the panel, which I sometimes call P, and then I have two Ps, and if those are in the same scope, then Java's going to get confused and say, wait a minute, you can't use the variable name P to mean two completely different things in the same scope. In this case, I've just named it poly for these examples, or if I was actually doing a particular shape, like if I was trying to build a star, I would probably call the polygon star so that I could remember, in my code later when I try to draw it, what it is that I'm drawing. Anyway, we use this add point method to add XY points to the polygon object, and then we use drawPolygon to draw the polygon and pass it the polygon object. All right, there are a few notes. The one that's kind of non-obvious and causes grief sometimes is that the add point method has to be called in a method that has access to the graphics object. For whatever reason, if you try to add points elsewhere, they don't get added. The other common thing is that we'll do stuff where we want the polygon to change, or we want to add new points to the polygon, or we want to move points that are in the polygon for some reason. And you have to be careful, because if you just keep adding points, it will make the polygon have more and more and more and more points. So if what you're actually meaning to do is say to shift it or to widen it or whatever it is, you need to remove all the points and then add the new corrected points to get the shape that you want. There are ways to do that. There's a clear method in the polygon that will erase all the points in it, or you can just reinstantiate it. You can say poly equals new polygon, and that'll also remove all the existing points before you want to modify them. This is an example. This is, to some extent, a bit of overkill, because these are hard to figure out the exact coordinates to get a nice looking star. But I'm going to create a new class. I'm going to call it DrawStar. It is an app, so it'll need a main method. So just starting out with the same kind of syntax. And I'm going to work through the same, let me zoom in. I'm going to work through all the same steps that we've done with every single app. So it is a GUI app, so I'm going to say extends JFrame. I'm going to make the constructor, which is DrawStar. I'm going to create the app. I'm going to set the size. Oh, come on. Let's get it even more dramatic a size here. Set the default close operation, and then show it or set visible to true. To do some drawing, I'll need a panel. And then I need to create the polygon, but we don't have access to G inside the constructor. The way we could try to get access to it is to say, graphics. Using the syntax in the chapter, we could say graphics G equals p.getGraphics. And you'll notice that, after I correct imports, that does compile. There's no errors. The problem is if we run it, let's just do it. Let's say G dot. Let's just do something with G. I'm going to set the color. I'm going to say color dot blue. Oh, I hate it when it does that. Okay, so this is not going to be a working app. But let's see what it does. Yeah, I don't know if you can see that or not. I can't zoom into that error, but it says there's an exception in thread main. The exception is a null pointer exception, and it's on line 21. So it's actually trying to give you all the information that you need to hunt it down. This is line 21. I've tried to do something with something that doesn't exist, something that's void or null. The only thing here that could be null is G. Color.blue is a built-in integer value. It can't be null. And I've called a valid method inside of G, so it's not null. So the only thing that can be null is G. And so the reason, again, is from what we talked about in the beginning of the chapter is you do not have access to the graphics object here. You cannot get it in the constructor. You have to wait until your app is fully loaded to get the graphics object. So I'm going to leave this stuff here because I'm going to move it where I actually want it later. But well, you guys can do this stuff wherever you want. The first solution is we're going to add a button, J button b equals new J button draw. Oh, come on. I'm going to move the panel declaration up here as well, which is more typically how we'll want to do it. In this case, how I'm going to code it will match what's in the keynote instead of doing something completely different. Then I want to add the panel to the JFrame, and this time I'm going to put it in a named region. I want it to go in the center region. So the syntax to do that is to say add p comma border layout dot center. And I want to add the button to the south. So the syntax is add b comma border layout dot south. And then I want to add the action listener to the button. So it's b dot add action listener, and you can say this here, or you can say new action listener, or actually there's a third syntax I'll use sometimes, which is even shorter. I'm going to say new action listener. Come on, hover. If you hover over there, it's not hovering. There we go. Add unimplemented methods. Okay, I just want to see if this will, there we go. Okay, so let me delete some blank lines, try to make this fit a little better on screen. All I've done is let me get rid of some more space. All I've done is attach the action listener to the button. I use this newer syntax we covered just a few minutes ago, and inside of the action perform method, I get the graphics and I set the color to blue. So let's run this. It's always good to test before we do anything wild. And my expectation would be that it's not blue when it loads because I haven't hit the button yet. It didn't get an error because I didn't try to get the graphics object while the app was loading. But when I press the draw button, that action performed should execute and should set. Actually, it's not going to do anything on screen. It's just going to set the drawing color to blue. And we haven't drawn anything. So we need to draw something. Let's just really quickly, let's draw a filled rectangle and do it at 100, 100, 200, 200. That should give me a large blue rectangle in the middle of the frame, but again, there's nothing there to begin with. We only get the drawing when you hit the draw button, and there's a big blue filled rectangle. Anybody try? All right, so now if you wanted to, you could paste all of the add points and the polygon code in there, and it would work fine. If you could draw a rectangle, you can draw a polygon. But so let's layer some other stuff on this. One of the reasons that a lot of introductory books teach drawing is to give you an easy way to kind of learn this coordinate system, the XY coordinate system that's kind of flipped, and then also to get you thinking about the order in which you do things and how that impacts what you see on screen. What you need to realize is simply that inside of this method, it's the flow of execution is top to bottom. I get the graphics first, then this color gets set to blue, then the rectangle is drawn. If I change the order, it's going to change what I see. So if I move the set color and put it after I draw the rectangle, the first rectangle we're going to see is not going to be blue. It's black. Now if I hit it again, it's still black. Oh, yeah, sorry, it's still black because I'm reinstantiating the graphics object. There would be a way to get around that. Let me see. If I wanted to see this. All right, let's see what that does. You don't have to make these changes. I just wanted to illustrate the order effect here. So, ooh, it does not like that. Null pointer exception, if G not equals null. Oh, I did it wrong, sorry. If G is null, get it. So, total mistake there. So we should get a black one, but then it should be blue after that. So why is that? It's simply because the first time this action performed is executed, I create a new graphics object and it has the default color, which is black. And then I draw the rectangle. I don't set the color to blue until after that. So the set color doesn't affect what's drawn above it. It affects what's going to be drawn below it. So let me add another little drawn something. How about a circle? So I'm going to say, well, let's go over 150, 150, and then do 50 and 50. And I'm going to change the, let's get rid of the weird order effect here, and instead let's draw a blue rectangle and then a white oval. All right, so now I've got two things I'm drawing. You'll notice they're drawn in the same location, but they'll get drawn in the order top to bottom that I've listed. So the rectangle will be drawn first, and then the oval will be drawn after it or on top of it. So let's double check that that actually works. There we go. So it's a tiny little circle, but you can see it. you can see it because of the order. If I change the order around and I grab the circle and I put the circle up here, we're not going to see it. The same exact stuff is drawn, however you want to think about it, but with the order reversed, the white circle is drawn first, and then the blue rectangle is drawn and it covers it up. So you could think that the white circle is behind there. I guess it is, but you can't see it because of the order we've done these statements in. So flow of execution is going to be top to bottom. And if you want to draw compound shapes, which involve multiple shapes layered on top of each other, then you really just need to pay attention to the order in which you draw things, the order in which you set the colors. I do have a little tool I wrote for the Java class called DrawTool, which lets you draw some of these using a visual environment where you can drag the shapes around and use menus to set the color and stuff. The cool thing about DrawTool though is it will generate the Java code for you. So if you draw something, you can then copy the Java source code out of it and paste it into Eclipse and get your drawing essentially done for you by the tool. But I'll introduce that towards the end of the chapter next time. Jumping back to the shapes, this is another way to see all the shapes. And so I've got an Eclipse window up on the next screen, which has the Eclipse draw code to draw these shapes. But I've blurred it out so that you can't really see it, because I wanted you to think through the shapes first when you're reading the chapter and going over it. So instead of me just saying, here's 6 shapes and here's the code to draw them, that doesn't teach you anything really. So the intention here is to say, hey, here's these 6 shapes, and you could draw all of them, but I've drawn them on a piece of this kind of virtual graph paper, so you can figure out all the syntax. You know the start and the stop, or the 2 points for the line are here and here. So the line, for instance, is one of the points is 20 over, 20 down, if each of the grids is 10 by 10. The other one is 80 over and 80 down. So those are the 2 numbers to get you that specific line. The rectangle, the top left corner, is at 70 over 20 down, it looks like. And then the width is 10, 20, 30, 40, 50, 60, 70, 80, 90. The width is 100 and the height is 30. So 130 would get you that rectangle. And you could figure out the other ones. I leave it kind of as an exercise. Well, I wanted it to be something that you could just almost make them out, but not quite, to make it just super frustrating. But I may have not blurred it. I may have not blurred it quite enough. It looks to me like lots of those you could see. In any case, the actual draw code is also in the chapter resource download that is linked here in the keynote. All right, so colors, we already covered it. So that was part of the goal of doing that starting example, was to ease you into this. These are all the built-in colors. There's an app in the chapter resources that's called Colors that is just this. This is Colors running. All it does is list the default colors and draws them and gives you the hex codes if you wanted to match them up with web design kind of hex codes. So it's just the 13 predefined colors. It's not a huge color palette. And yes, you can use brighter and you can use darker to lighten and darken these. You could take any of the grays and lighten and darken them and get little steps kind of in between white and black. And same thing with the regular colors, but obviously we're missing colors that you might legitimately want to use. I mean, there's no brown, there was no gold. That's where we've got to come up with our own colors, mix them ourselves using RGB values. Or you can look up, if you have a favorite, for instance, gold hex value from web design or from another class, you can use the syntax to use that hex color to create the gold that you want. In addition, we do have control over transparency, which I didn't show you, but in addition to RGB values, you can pass a 4th value, which is another floating point number, float, that varies between 0 and 1, and it's the transparency of the color. So I've got these sticky notes lined up at the bottom of this slide on the Keynote Live, which is varying alpha values from 0.1 all the way up to 1. And you can see 1 is not transparent at all or fully opaque. And as I dial the transparency down, what you're seeing is it becomes more and more transparent or less and less opaque. So you can stack colors up or stack shapes of varying transparencies up on top of each other also to get some cool techniques. We already talked about setting the drawing color using setColor. Again, the thing to note is this down here. Note, setting the color doesn't change the color shapes you've already drawn. This is totally top to bottom. So when I set color, it only affects what I draw after that or below that set color from a top to bottom standpoint in my app. That's exactly what you would want. I don't think that should be a surprise, but it does throw some people. When I set the color blue here, say on line 38 of my version, it doesn't go back and change the circle to blue. That wouldn't be what I wanted. If it did, I wouldn't be able to see the circle because everything would be drawn in blue. So the set colors only affect subsequent draw or fill statements, not statements that are above it. I think that's exactly what you would want. Fill and shapes, in addition to the basic draw methods, there are parallel methods called the fill methods. There's no fill line because you can't fill a line. The one that people get confused about maybe is, well, okay, wait a minute, what about an arc? An arc is just a line. You just said you can't fill lines, but you can fill arcs, and what you end up with is something that looks like a pie wedge. Okay, but text. Let me introduce text because text is kind of the outlier and something I want to give you time to think about before class Thursday so that you can successfully put text where you want it and get it to look like what you want. One way to draw text is using the draw method drawString. DrawString is built into the graphics object, and it takes 3 parameters: a string that you want to draw, and then a location, a pixel location, 180. So that would draw the text hello world 100 pixels over from the top left and 80 pixels down from the top left. DrawString needs all 3 of those parameters in that order, so you have to pass it a string and then an integer and then an integer. All the draw methods require that. Anything that they expect to get, if you don't send it, you'll get an error. Or if you send a decimal value instead of an integer value, you'll get an error. Sounds tough. I just told you the drawstring is kind of the outlier and made a little bit of a big deal about it. And yet you may be looking at that and thinking, how is that anything an outlier? So next slide. So the question is, where does the text get drawn? I mean, I just told you it was 80, 100, or whatever it was in the previous slide. Here's a second example, which I've got 2 drawstrings, and let's look at the bottom one first. So it says g.drawstring pirate pizza restaurant, 60, 80. You may be looking at that and thinking, well, how's that confusing? Is that confusing? It says 60 and 80. That means 60 over from the left and 80 down, and you can see right here, I pointed out 60, 80 on the graph paper. And hopefully I've counted correctly. That should be 6 squares over from the left and 8 squares down from the top. The thing is, you might have picked up on this, is that's not the top left corner of the text. Everything else we draw, the location is the top left corner. Not with Java text. It is the very leftmost pixel, and it is the line that you would draw if you were underlining it. It's not the bottom, technically, because any letters that descend would descend below 80. It just so happens the Pirate Pizza restaurant doesn't have any descenders, but if we add them, they would dip below the 80 line. So the location, that 60, 80 is the very leftmost edge of the text, and then the location of the underline that would go, or the baseline is what it's called, of the text. Why is that important? You may be thinking, that's not that big a deal. That's only 10 pixels, what, 15 pixels difference? What's the big deal? Well, it becomes a big deal if you want to put text exactly where you want it. If you want something in the exact center of a shape, you'll get really frustrated by it not appearing to show up easily where you're trying to put it in the center. And in addition, one of the common things people do in writing apps is they'll decide, hey, I need a title for the app of some sort, a heading, and I want to put it up in the top left corner, so I'll put it at 0, 0. Well, if I put it at 0, 0, like this top example, I've put can't see me 0, 0, and don't let this throw you. If you want to put a quotation or a single quotation mark inside of a string, you have to do what's called escape it. And the escape character in Java is the backslash. So but in any case, this would put it up here. And you can see I've actually kind of graded out to emphasize the fact that you won't be able to see that. It'll be above the very top of what's drawn. So Java's happy, maybe gleeful, to let you draw stuff off screen. If you get, it will draw it wherever you tell it you want it drawn. Even if that's way over here off screen, it'll do it. It's not an error. In other words, you're not going to get a compiler error or warning of any sort that says, hey, that's not going to be visible because of where you put it. You won't get that warning. That's the first complexity with strings, is just to realize the placement doesn't follow the exact pattern of all the other stuff we've been drawing. It uses its own pattern. Fonts are easy, and let me just mention that there's a font class, capital F font, and we can access any of the named fonts that are installed on your computer just by naming the font. So the syntax is font, some valid identifier, equals new font, name of font, and then two numbers, a style number, and they're built-in constants to let us not have to remember the numbers. So font.plain behind the scenes is an integer number, which is interpreted as plain font. If you want a bold font, it would be font.bold. And if you want italicized, it will be font.italic. And then a size, this is the height of the font in pixels, which is roughly equivalent to the point value. And then you set the font using a method called setFont. So this works very much parallel to colors. You might be thinking, in colors, we set a color using the color class, color, C equals new color, and then we use setColor to set the color to that drawing color. Fonts are the same ways. We create a font object using the font class. It could be font F equals new font, etc. And then we use setFont to set the font to that selected font. And just like colors, the font change will only affect text that you display after that. So if you've already drawn something in a font that's different from the font you're changing it to, it will remain drawn in the font that you drew it in. Just like colors that you drew previously will stay the color you drew them in and not take on the new color. So if I want to draw some text, I'm going to say g.drawString. I want that second one. Let's say hello. And I just realized I've rearranged the order in here, so I'm going to also have to rearrange it back to get it to work right. But let's put it at 200, 200. And then I switch the order of these so that they're screwed up. So let me put it back to the way I had it originally, which is draw the blue rectangle, draw the white circle, and then let's get another set color in there just so that you get it. And I'm going to do color.light gray. All right, let's see what it looks like. If you're following along, you should have a decent idea. We should still see our blue rectangle, our little white circle, and then some text. Hey, there it is. That is kind of small, but if you're following along, you should see something like that. And the thing to note is, where is 200, 200? 200, 200 is in dead center of this rectangle. And it's actually right also at the bottom of the H. So on your screen, if you've used my numbers, which you certainly didn't have to, but what you would see now is that the hello is offset to the right. It's not centered in the rectangle. And it's also offset vertically up. So it's higher than the center of that blue rectangle, and it's to the right of the center of that blue rectangle. Even though 200 and 200 are dead center in that rectangle, it all hinges on what does 200 by 200 mean? What does drawString do with 200 by 200? And drawString takes that and says, okay, that's the leftmost location of the string, and it's the baseline of the string. It's right there at the bottom of that H. It's not going to put the text in the center of the shape. If you want it in the center of the shape, you'll have to do more work to figure out how wide hello is, how tall it is, and the font that you're using, and stuff like that. Let's change the font real quick, just because we did just cover that. So instead of the default font, let's say new font. How about Courier? How about bold? And how about, let's do something bigger. How about 44? All right. That should get us something that looks like that. So different. Here's on the left is the original default font, and then on the right is Courier. And you can see the 200 by 200 location is still exactly at the bottom left corner of that H. That's dead center on that rectangle. All right, questions? Anybody? I've got a second poll. I'm stopping on this slide in the Keynote Live, which is slide 24. And we'll pick up here the different fonts. And I've got a little app in the chapter resources called FontAndColorPlayground. So if you haven't taken the time to download the chapter resources and put them somewhere and figure out what's in them, you might want to do that before class next time so that you can run FontAndColorPlayground easily and follow along. And same thing with DrawTool. And you might as well also find the ArcPlayground and play with that a little bit. But we'll pick up here on what fonts. So you guys who are listening live, I'm just curious, what was the first programming language that you learned? All right, so we're seeing some basic. AppleScript is a Mac scripting language that lets you script anything on your computer, which is really cool to learn. Lua was the language you learned in the mobile development class. Java is what we're learning now. So for some of you, either this is your first language in this class, or you learned Java previously, in high school or something. I get a lot of that, and now you're gonna really master it. And then Python would be for the Python. I have Lua twice. Why do I have Lua twice? Very sorry. That actually should have been Pascal. I just mistyped it. Sorry, I'm ending the poll just so that you guys can see it and to bring us to a close. If there are any questions, I will hang around as long as there are. But I am done with the material for today, and we will pick up on this slide what fonts on Thursday. Yes.
What's the homework check on Thursday? Is that you said over the chapter 4 problems?
Let's have a look. Yeah, that's not on Thursday anymore. Yeah, so right now the homework check is on the 22nd, which is also the career panel. If you guys are MIS majors, that would be great to attend, and they will be taking attendance apparently, and you can get an added doubloon if you do attend the Zoom career panel session.
I'm wondering, what's the lab day look like? Do we just talk with each other, or we do some lab, or because I saw it's on the syllabus.
Right. Now I will email out either the night before or the day of a lab day activity, a challenge. So it'll be to program something. The first one involves a lot of drawing, so it'll test your ability to build an interface with the panel and the button and to draw something.
Okay.